So Gustavo will be in the panel. So for the sake of time, yeah, let me invite the colleague, which is Jorge, right?
Good morning. I will present other project that CPQD is working. That's the 5G range. It's another project inside the H2020. It's related with 5G as well. With these partners, we are working with these partners, Brazil and Europe. And going straight to our project problem to solve is the question regarding the internet access around the world, that we still have big holes concerning the internet access. So we have many parts of the world to provide internet service. So the proposal is to provide this service, but in a feasible economy way. So how to do that? The first point is to use a unlicensed spectrum, because spectrum licensing, as you know, is very expensive. So one option is to use the white space, or the TV white space. That means that depending on the place in the world or here in Brazil, there are places that the TV channel is not used. It's free, it's vacant. But why 5G? And why not use 4G or LTE? The point is that 5G is bringing a new waveform that's have more efficiency. It's more efficiency in terms of spectrum usage. And because the new waveform has a low out-band emission, meaning you have a low slope, more vertical slope in the sideband of the waveform. So you have, with this new waveform inside the 5G, you can have more efficient to use white space sharing with another users. Besides the TV station, we have to share this spectrum with other incumbents, like the microphone signals, that's a narrowband signal, or other standards that already use this space, white space, like the IEEE H2.22. So coexistence and not interfere with the others users and the TV signals is demand or mandatory. So like the other project, we have 4 work packages. We are now in the work package 6 and 7, so almost in the final step of the project. So going straight to the solution. So I show the problem, but how to integrate, how to use the white space in the 5G, because 5G is not predicting or not studying anything about the cognition or use the white space inside the standard. So to use the 5G white space, we have to integrate the cognition in the system, along with the new waveform. In our case, we are using GFDM. That's one of the options, supposed option for 5G. To integrate this cognition, we have to work with a cooperative sensing, meaning that many UIs, many terminals need to sense the spectrum, white space spectrum, and to see if there's signal of primary user, that's the TV station, or other secondary user like the microphone signals or IEEE H2.22 users. So we have to include this sensing function. And in the world of the sensing cognitive function, we have to integrate many steps, not only the sensing. We have to include the knowledge base, select user, because you cannot afford to think that all UIs will sense the signals all the time, because there's a problem of the power usage for that, use of the control channel, and we have to think in terms of efficiency. So, thinking about knowledge base, we have to perhaps include the artificial intelligence or machine learning to define which terminals will sense the environment. So we include all these capabilities in this 5G system. At the end, all these cognition functions have to deliver this in the yellow, the spectrum hole information, or the channel that's vacancy that the 5G system can use. So at the end, the cognitive function have to deliver this information of spectrum holes. With that, the 5G range system can use these holes to allocate resources. Allocate resources meaning fulfill spectrum with user data information to transmit data. So this is a big picture of what I mean. So having these spectrum holes in yellow, for example, we have 4 channels. Each channel, TV channel is 4 megahertz bandwidth. We can aggregate one or more channels. And the spectrum sensing function provides this spectrum holes footprint that the scheduler in the MAC layer can use this, all these grids is the resource that the scheduler can use to allocate users' data. So, for example, we have a detection of a primary user TV station, where there's this detection, the MAC scheduler cannot allocate resource. And we have these narrowband signals. That's, for example, microphone signals. So we have this. We have to think about all these different signals to coexist, and they also use the spectrum in a more efficient way. So it looks like simple, but it's not so simple like this. But, well, at the end, we're in the final step. We are planning to implement what I thought, what I defined in the architecture. We have a POC to implement this solution of cognition And the physical layer using GFDM, we are planning to use a software-defined radio. This is the main equipment, but this is not showing the power amplifier. We have to use a power amplifier because we are planning to use it or cover like 50 kilometers of the cell size. So we have to have a good power amplifier. Besides that, we are trying to standardize our plan or architecture for integration of the cognition cycle inside the 5G, inside the 3GPP and the ITU, and we have to think about Anatel because to have this solution, there's a problem of the power, because to provide this 50 kilometers, we have to change this the power limit, mainly in the terminal, because the base station, there's no problem, but the terminal needs to have a power signal higher than the Anatel is proposing. Well, that's it. It's a quick view and snapshot of this project. Thank you.
Okay, thank you, Jorge.